Okay, hi everyone. Today we're presenting our research titled Performance Comparison of CNN and Vision Transformers Models in Fruit Quality Detections. Next. This project was done by Hiskia Aldrich Jericho and me, William Kurniawan, with guidance from Dr. Alexander Agung Santoso Gunawan and Mr. Rilo Chandra Pradana, SI MCOM. Next. This is the introduction part. Next. Food quality is important for food safety and customer satisfaction. Manual checks are inconsistent and don't scale well. CNN are great at capturing local features but miss the big pictures. VITs with self-attention are better at understanding global patterns. This study compares the two models for classifying fruit quality. Next. This is our research objective. There are 3 points in here. We aim to compare CNN and VIT for fruit quality detections. Second, we evaluate their performance using accuracy, precision, recall, and F1 scores. The third is see which model is better for real-world use. Next, this is the literature review parts. Next, manual inspections in agriculture is tiring and inconsistent. Traditional image processing is limited, but CNNs improve things by learning features from image. Still, they struggle with class imbalance and fruit variation. So we need stronger models. Next, deep learning is now widely used in agriculture. For example, in fruit assessments and disease detections by analyzing features like color and shape. CNNs help automate the inspections, making the process faster and more reliable. Next, this is the methodology part. Next, our process starts with data collections, then exploratory data analysis. Next, we clean and prepare the data through the normalization and augmentation. Then we split it into training, validation, and test sets, the three sets. And then we train CNN and VIT models, evaluate them using standard metrics. Next, this is the dataset details. We use Kaggle datasets of fresh and rotten fruit like apples and bananas and etc. It had class imbalance and lighting variations, so we applied stratification and augmentation. This helps the models deal with real-world image issues. Next, this is the technical details. First, images were resized to 224 times 224 and normalized. We use flipping, rotations, brightness change for augmentations. Data was split to 70% for training, 15% for validations, and 15% again for testing. CNNs use local filters. VIT use self-attention for global features. We use scikit-learns to calculate accuracy, precision, recall, and F1 score. Next.
Okay, in this part, we will discuss about a result and discussion. Okay, and this slide shows the evaluations result of the convolutional neural networks or CNN models in classifying fruit quality, specifically between fresh and rotten fruit. The CNN model managed to achieve an accuracy of 76%, which shows a fairly stable and balanced performance. We can see from this table that the precision recall and F1 score values for both classes, fresh and spoiled, are in the range of 0.76 to 0.77. Interestingly, the recall for the spoiled class is slightly higher at 0.78 compared to 0.75 for fresh. This means that the model is quite sensitive in detecting damaged or spoiled fruits, which is very important in the context of food quality control. In addition, the macro average and weight average values are also similar, indicating that the dataset is relatively balanced and the model is not biased toward any one class. This makes CNN valuable enough to be used as a basic automated inspection system. And then in this slide, we see the evaluation result of the Fission Transformer or VIT model in food quality classification. The VIT model shows an accuracy of 83%, which means it performs higher than the previous CNN models. We can see that for the first class, the model achieved a very high precision of 0.89, meaning that the prediction of fresh fruit by the model is very accurate. While for the spoiled class, the recall reached 0.88, indicating that the model is very sensitive in recognizing damaged or rotten fruit. The macro average and weight average values for all metrics, precision, recall, and F1 scores are in the range of 0.83 to 0.84, indicating a balanced performance in both classes with such robust and stable performance. The VIT model is very suitable for use in fruit quality inspection system, especially in application that requires high accuracy and sensitive, such as quality control in food supply chain. And in conclusion, so in the conclusion for the result and discussion, Vision Transformer outperforms CNN in food quality classification due its ability to capture global visual patterns using self-attention. Unlike CNN, which focus on local features, VIT can detect subtle and scattered hues like bruises or discolorizations. Therefore, VIT is more effective in recognizing small changes that determine between fresh and rotten fruit, making it a superior choice in image-based quality inspection system. Okay, in this part we will discuss about conclusion. In conclusion, we found that the Fission Transformer or VIT model outperformed the convolutional neural network or CNN in classifying fruit quality. VIT yields higher accuracy up to 90% and better overall performance in additions. VIT also shows more stable training and stronger generalization capabilities. This makes VIT more reliable for application in real-world conditions for future development. We recommend that the datasets be expanded and additional data types such as textures, spectral data be added. We also suggest real-time performance evaluation so that the model is truly ready to be used in real agricultural quality control system. Okay, so this is our presentation on the performance comparisons between CNN and Vision Transformer model in detecting fruit quality. We hope this research can contribute to the development of automated quality control system in agriculture. Thank you for your attention and time.